This video is talking about the squeeze theorem. We wanted to know how we are going to be able to apply squeeze theorem to evaluate limits of some functions. The statement of the theorem says, suppose that we have a relation between three functions as follows. G of x is going to be greater than or equivalent to f of x, less than or equivalent to h of x for all x's in some interval CD, except maybe possibly at one point a inside that interval, and that the limit when x approaches this number a for function f of x is equal to some number L, and it's also equivalent to the limit when x approaching a for h of x. Then the conclusion of this theorem says that the limit when x approaches a for g of x is also going to be equivalent to L as follows. Let's see how we are going to apply this theorem to evaluate limits through the next example. In this example, you've been asked to evaluate the limit when x approaches 0 from the left for x cubed sine 1 plus 1 over x. Now, if you wanted to evaluate such a limit like this one, and you wanted to use the squeeze theorem here, then there is some steps you have to follow. The first step is that we need to find two functions, f of x and h of x, such that x cubed sine 1 plus 1 over x is going to be greater than or equivalent to f of x and less than or equivalent to h of x for all x's in some interval containing 0, except possibly at the point 0 itself in that interval. The second step is that we need to evaluate the limits for these two functions. So the limit when x approaches 0 from the left for f of x is equivalent to some number L, and it's equivalent to the limit when x approaches 0 from the left for the second function h of x. If this is the case, then that allows us to use the conclusion of the squeeze theorem. Now let's see how we are going to apply these steps. First, we start by the following inequalities. Now we know that if you are dealing with sine or cosine function, then we know that both of these functions, their values is always going to be between -1 and 1. Now remember, that is you are approaching 0 from the left, so that means values for x is going to be always less than 0, negative numbers. So that means if you are cubing x, then that's also going to be a negative number. Hence, if you wanted to construct your function, which is x cubed sine 1 plus 1 over x, you are going to multiply your inequality all through by x cubed. But be careful. Now what you are multiplying by is going to be a negative quantity. That's what reverse the sign of your inequality. And you are going to get x cubed sine 1 plus 1 over x is going to be less than or equivalent to minus x cubed and greater than or equivalent to x cubed. In this case, the function that is f of x is going to be minus x cubed and h of x is going to be x cubed. So we satisfy the first hypothesis of the squeeze theorem. Now let's see what is the limit when x approaching minus infinity for both of these functions. Since the limit when x approaching 0 from the left for minus x cubed and for x cubed is going to be, both of them is going to be equivalent to 0, we satisfy the second hypothesis of the theorem. Then we are able to use the conclusion of the squeeze theorem, which will allow us to evaluate the limit when x approaching 0 from the left for x cubed sine 1 plus 1 over x, and this limit is equal to 0 as well.